Good evening, everyone.
Good evening.
Good evening, sir.
Today, our guest lecturer, Dr. Tilak Sebalapidia, graduated from University of Moratuwa, Sri Lanka in 1982. He obtained a first class in electrical engineering and one of the two from our batch. He earned a PhD in electric power engineering from University of Cambridge, UK in 1988. Over 1982 to 1998, he worked in electricity utilities in Sri Lanka and the Middle East. Since 1999, he works as an international energy consultant, conducting design and due diligence on energy sector projects in South and Southeast Asia, Central Asia, and East Africa. He was the president of Sri Lanka Energy Managers Association from 2004 to 2006. He is a visiting lecturer at universities of Moratuwa and Jaffna on electric utility industry and efficient use of energy. He is an excellent teacher, presenter, who is invited for many seminars and these days many webinars. I will briefly outline. I have shared this with you, Dr. Sebalapidia's presentation today. Project financing requires careful evaluation of projects for their technical and commercial feasibility and compliance with legal requirements. Poorly designed projects are frequently processed in a haste to satisfy various other objectives, often resulting in failed projects. We have seen most of the government projects have gone through that. Non-performing loans and widespread displeasure and losses. The session will cover the presenter's experience in the energy sector in Sri Lanka and the region, both with government and private sector projects financed by commercial banks as well as international financial institutions. I have shared with you how we as a consortium obtained his services when Aitken Spence approached us for financing 2 thermal power projects. Please get maximum knowledge from him, and if you have any questions, you can ask him and get maximum from him. Dear Tilak, floor is yours.
Thank you very much, PL, for the kind words and the extended biodata you read. My biodata is usually about 4 lines. I think you picked some other sentences from various places. I would spend more time to talk to you rather than talking about myself. So welcome and thank you. And I believe you can see me. If connection difficulties pop up, I will switch off my video. But until then, I will keep it on. So I believe, PL, we have 2 hours, and I will generally go slow as I do, so that I give you enough time to develop your thought process and put yourself in the case studies that I will be bringing in. Of course, given the time available, I will go deeper into one case study, but likely into others as well. And in the middle, relating anecdotes of things that we came across, difficulties we faced, and shortcuts we have seen being taken by investors and the bankers as well, and some stories of successes as well as failures. So, of course, to guide my presentation to you, I have prepared a few slides. So let me share my slides. I hope sharing has been enabled.
Yeah. You go bottom of the screen at present now.
Right.
Then
yes. Okay. I have it here.
Go to your entire screen.
All right. Now,
all done. Yeah. No need to explain to you how to do it.
Yes. Now I think you see my screen.
Yeah. You can
so basically, project appraisal and due diligence.
Like if you want to take a break after 1 hour, you can take, or you can go.
Yes,
2 hours.
usually I go on for 2 hours PL.
Right.
So, so therefore, if there's a difficulty, I will let you know and mute and take a break. Otherwise, I suppose since you are mostly listening, for you it should be okay, right?
Right. Yeah.
So,
Positive.
but please do ask questions, stop me. And since I'm an electrical engineer, I don't mind being asked, simple things about electricity as well. Um, while we talk about more difficult and serious matters related to electricity. So let me organize my screen a little bit. Fine. So, project appraisal and due diligence. My theme is where can things go wrong? So, basically relating on my, sorry, sometimes it goes too fast. So, anyway, a wind power plant project that we conducted technical feasibility on and how the project's done and about other projects, successes and failures. So, of course, working in the energy sector, you will have to expect energy, electricity related case studies from me. I have not conducted other types of case studies or due diligence work. It all revolves around electricity. So, um, then, of course, I will talk a lot about the wind power plant project and how it was achieved and why I consider it to be special. And then briefly, a transmission line project in Bangladesh and some similar experiences in the region, as well as Sri Lanka's railway development, upcoming railway development project. What are the issues? What are the features? Where can things go wrong? And in fact, where have things gone wrong? All right. So sometimes my slides are not moving, so let me see what I could do about it.
Is it PowerPoint or?
Yeah, it is PowerPoint. Let me see.
Okay.
Sometimes it suddenly moves. All right, I think now it's all right. Okay, now it's all right. All right, so now the story. How private investments flowed into wind power development. Later, if you want to talk about solar, we can talk about that as well. So until 2008, there were no wind power plants in Sri Lanka. Of course, there was one. There was
And
one, which
Hambantota.
was uh, which was a relatively small private power plant in Hambantota. So that being in Hambantota has no relevance to the center of power as well as the port being done in Hambantota. This pilot project was built in 1999 with World Bank financing. So,
Yeah.
apart from this trials, relatively small power plant, some of you may have seen it when you traveled that way. Sri Lanka had nothing, and there was an open offer to the private sector, and thereby to lenders to finance it to build private wind power plants. And the offer was open since 1996, but there were no takers. Why? In my assessment, the price was not adequate. Then, secondly, the resource data. How much wind is available? As you can imagine, it is a technical requirement for adequate wind wind power. That means a wind flow to be available for you to fix a wind turbine and let it rotate, produce electricity, and sell to the grid. Of course, many had doubts on whether it will work in Sri Lanka because these are not going to be tiny wind turbines in your backyard. These were going to be commercially viable projects. So they should make good financial sense. Now, looking at it today, There are 18 wind power plants, out of which 17 are private, one is CB owned. Meanwhile, the tiny 3 megawatt Hambantota project came to its 20-year end of life, and it has now been removed. Now, why I selected this example is because in this case, the private sector went ahead of the government sector, that is CEB, to build commercial scale wind power plants. So let us see how it was done. Of course, just to break the monotony, I'm showing some pictures to you. On the left-hand side are the blades of the wind turbines in Puttlam that were fixed in 2010. That's almost a full 11 years ago. And each one was 33 meters long. Now you would recall a long container truck is 40 feet. 40 feet. So that is about 12 meters. So 3 times the long container truck is the length of one of these blades. So it was a challenge to transport this. Now look at the picture on the right hand side, how the technology developed. So in 2010, the transport contractors were struggling to take these long blades across the curves from the Colombo port to Puttlam. On the right hand side, a special vehicle in which you mount the blade, and this blade is 50 meters long. 50 meters is 4 times the container truck. And with a special attachment, the blade turns all over. If it wants to avoid the electricity wire, it can be lowered. If you want to take a curve, you can raise it and take the curve, avoiding the trees. So likewise, technology improved, and this picture on the right hand side showed the transport operation during the last lockdown. So when all of us were confined to our houses in March and April, these transportation activities happened between Trincomalee and Manor, from the east coast to the west coast. Anyway, uh, how the foundation looks like, because whenever I go to site with bankers, they are very interested in what is there and what do these things look like. So the foundation of a wind turbine looks like the roots of a coconut tree, because sometimes I say the designers of a foundation of a wind turbine would have studied the fruits of a coconut tree, because it's tall and foundation cannot be enormous, so it has to be of limited size, and they are standing. So small one on the left hand side and large one on the right hand side. This is my last picture for now. The completed project on the left hand side in Puttlam, and the completed project on the right hand side. So what I want to emphasize is that technology is changing. Technology is changing. Generally, when other things get smaller and smaller, projects in industry, whether it is electricity or any other manufacturing industry, they get bigger and bigger. And why do they get bigger? That is because they are more efficient when they are bigger. They can capture more wind and produce more electricity when it is bigger. So therefore, the size matters, and together with it, we get a lot of problems. Now, having seen these pictures, we'll get back to where it started. So one fine day, a potential investor knocked on our door. We did not know him before. He knocked on our door. He did not care to telephone and make an appointment and said, I am so and so. I will withhold the name. I'm so and so. I'm terribly keen in building a wind power plant. Can you assist? So in my team was the person who designed the Hambantota small wind power plant, which was at that time 10 years old. Of course, in the media, there was a lot of positive publicity as well as negative publicity. So I will start with negative publicity. There were people who were saying, look, wind power might work in other countries, but I am sure in Sri Lanka it doesn't work. Because what Sri Lanka has are doldrums. Doldrums are basically trade winds. You know, the boats that were sailing, they move around using trade winds, which are very slow moving masses of air. Then when you actually look at the information, technically, the data was not there on wind speeds. Obviously, you cannot make an investment based on individual perception. I'm sure you have seen people writing to newspapers saying that when I went to Namanukula, there was a huge blowing and I also fell on the ground. And therefore, this is where the wind power plant should be built. I would say never build a wind power plant there. Why? Because you have been subjected to a short-term gust of wind. So therefore, what is required is long-term measurements. Now, this is where the desire to go for technical perfection becomes important in a project. Sometimes lenders are very cautious about it, and we have seen many times where lenders have not paid adequate attention on the technical data on which a project is based. So absence of wind flow data was a handicap. So this investor is pressing us, can you look for a site? I'm willing to invest. And the government says that I can build a power plant and sell electricity to the grid. So we did assist him. And which finally, as I'm going to tell you the story, which finally resulted in the first commercial wind power plant in the country. But it was not plain sailing. Land availability was a problem. There were many legal issues. Price paid for electricity produced was not enough. The financial viability was an issue. Bankability, as we collectively call all these issues, was a concern. And the overall fear as to whether will it work or will it fail. Because if it is a government project, the government or CEB will cushion itself. If it is a private project, true, electricity production so far mostly is done by the government or government agencies. With private sector going in, they have to be viable projects. So things that private sector did not do before were being done. So the question is whether it will work technically and whether it will be financially viable. So our role was not to be mad about the project, because that is one thing that I never do. Of course, in the society, I'm sure you meet a lot of people who are mad about sustainability, renewable energy, solar power, wind power, hydropower, things that are glamorous. But we as consultants who are supporting at times project developers, at times the lenders, we have to base our opinion on facts. We cannot actually be mad about anything. If a project doesn't work, we have to tell our client it doesn't work. We have to tell our client lender that this is not a good project, don't touch it. So if I move further, in 2008, we are, if we wind the clock back 13 years, there are several ingredients for wind tower development that moved into position. Sorry, there is a repetition of the phrase, moved into position. The first thing is that the price paid for electricity production increased to viable levels. That, of course, the government did as a result of a policy change to encourage renewable energy development. The price paid for wind power increased. Then, secondly, I told you the wind data was a problem. The government decided to share the data that they have in Putla with potential investors. So the data problem to a large extent was resolved. At least there was 3 years of good wind flow data. Then the legal and regulatory process was streamlined with the establishment of the Sustainable Energy Authority. So by the time the key ingredients fell into place, now there emerged a challenge. There were about 10 investors interested, as we heard at that time, and 3 of them very seriously. And who will do it first? Who will do it first? Because some of the ingredients are okay, but the other ingredients does not seem to be okay. And it's a first in the country. Will it work? There were certain specific technical firsts required as well. So you can imagine these are 60-meter tall towers. And Sri Lanka did not have a crane that could lift 300 tons and keep it on top of a 60-meter tall tower. So can you imagine the crane had to be imported? So when the project was actually done, our client imported a crane. He brought a crane, not only the crane, but the crane operator also from India. There were no operators who are certified to operate that kind of tall cranes lifting heavy loads. Now you might say, oh, there are so many cranes in the country, so many buildings are going on, but those are fixed cranes. And this crane is crawling. This crane is crawling. I will show you a picture later. And it had to lift 300 tons. 300 tons, you can imagine how tough it is, right? 300 tons, maybe 10 heavily loaded lorries, lift it and keep it on top of a 60-meter tall tower. And you can imagine if the wind flows when it is lifting, the load will swing. So therefore, this particular crane has it has a small wind turbine. So if the wind turbine or the wind measuring system says the wind velocity is too high, the crane operator says, I'm going to stop. Because it might swing and cause his crane to be unstable. So these were the practical difficulties. Then if we go on further, the question of who does it first. I will come to the lender's perspective in a moment. So the usual development process was followed with added safeguards. So a good feasibility study was the starting point. And we did the feasibility study for the client, which I will give you some extracts from the feasibility study. I know some lenders are very thoughtful and very cautious and read the feasibility study, or some people call it the project report. That's fine. Read it carefully. And some lenders are careless, and therefore either the lender or the client or both of them could possibly get into trouble. if the project feasibility is not diligently conducted and evaluated. So the project feasibility, however much we too like wind power, was developed on the basis of facts. Was developed on the basis of facts. Now, one option is, say, for example, equipment supply. So our client could say, look, I know of a crane supplier in India, we can get it from him. But then we as
I think
consultants...
your connection is not very good.
Sorry?
Yeah.
Sorry? Can you hear?
We can't hear you. It's breaking.
Now is it okay?
Okay, yeah.
Or should I reconnect?
Also, we can hear you.
Now okay? Right.
You're connected. Yeah.
Right. Yes. Okay. Fine. So maybe some connection interruptions which I did not see at this end. Anyway, so the equipment supply as project consultants to the client, we could have said, oh, you know a crane supply, so that's fine. No, we wanted to document. We wanted to document how many crane supplies of this type are available in the region. We wanted data, and we wanted to include it in the feasibility report and cross-check by talking to those people. Then similarly, you saw the equipment is heavy, long, tall. So therefore, we could have said, all right, you can bring it from the Colombo port. Maybe you can bring it. No. In fact, we spent a lot of time in meticulously planning the equipment supply and delivery, the delivery logistics. Would you believe that they had to break a wall in the Colombo port to take this equipment out? They had to break a wall. And in the Putlam, the road to Kalpitiya starts a few kilometers before Putlam. And the curve we had to take at that junction was 90-degree curve. And this 35-meter wind blade could not be taken in that curve. So therefore, one or two corner shops had to be demolished in that junction, and the developer had to pay for it. So these were all things that had to be studied in advance to make sure that there are no unforeseen problems. In fact, our client told us, and we agreed, that before the equipment arrived at the port, he did a dry run on the road by fixing a structure which was as tall and as long as the real thing. He created a dummy and transported it in the night from Colombo to Putlam, just to make sure there will be no unforeseen problems. So the feasibility study, before doing all that, the feasibility study had a comprehensive equipment supply and delivery study. Then, of course, the financing. We did talk to a number of lenders. Remember, we are still in the feasibility study stage. We have still not signed any agreements. And the year was possibly 2007, early 2008. So we were talking to lenders, what is your appetite for this kind of projects? It's going to be a first. Then, of course, we had to make certain assumptions as to about the lending terms by looking at how money is lent to similar projects. Remember, we still have a good renewable energy industry in the mini hydrosphere. So the bankers were quite used to the mini hydro projects, but wind power was the first for them. Then, of course, finally, and most importantly, it's the first time this equipment is going to come to Sri Lanka. There's no experience in the country in maintaining this equipment. We, as consultants, we too did not know how to maintain. Of course, can we know how much of oil to be placed and what tools to be kept? No, we don't. So therefore, our client decided that there will be a maintenance contract given to the equipment supplier himself, installation and maintenance, with the objective of gradually training local people to maintain the power plant after a few years. So these were the the additional features that was investigated in the feasibility study and documented. So now the feasibility study, I know some projects carry very simplified reports. I have seen feasibility studies of failed wind power plants which never took off the ground. So these are some of the alternative strategies that we analyzed. Now, what are we analyzing here? This is an extract from the feasibility report as a result of a study of two different types of wind turbines. Let us say it's two different types of equipment. So what is the additional benefit? So the red one will produce a smaller amount of electricity given a particular wind speed, and the black one will produce more. Is the feature of this equipment matching very well to the wind flow patterns in Putlam? So as you can imagine, there was a heavily technical assessment to be done. In fact, there are companies in the world whose only specialty is assessing the wind climate. In fact, we actually consulted a specialist in wind climate as well. Because remember, as consultants, it was the first for us as well of this scale. So therefore, we consulted a wind specialist who can interpret the wind data and help us to match the equipment in the market with the wind flow pattern in Putlam. So as you can see, different equipment performs in different ways. So just to give you a flavor on the depth to which the project feasibility study went. Remember, this was about a $14 million investment. At that time, it was exactly 1,400 million rupee investment. So you can assess the scale of the project. It was, although physically it was big, it certainly is not a project of hundreds of millions of dollars. And it's not a project as tiny as $1 million. So it was a project of the order of about $14 million at that time. So that was a financial the investment magnitude and a good assessment of the construction schedule. So I'm just giving you some extracts from the feasibility report. So this was the schedule we prepared most likely in late 2007, and the various activities, data collection, reaching financial closure. And now looking at this 12 years later, I'm in fact surprised that some of these things we did so fast, given the difficulties and the problems we had, because we were the consultant for the feasibility study, and the client said, you must stand by me right through the implementation up to completion and commissioning and 3 months into operation as well. So we were tied up by the client to say there is a good project and sit by him when he negotiates with equipment suppliers, negotiates with lenders. I have so many stories on and experiences, and then conduct all the other supporting studies, help with all the approvals, and conduct the social and environmental studies, of course, with some additional specialists from those fields, and conduct the noise impact of wind turbines, because in manufacturing industry, noise is a main problem. So similarly, this equipment also emit noise. So there had to be a noise study. So likewise, a variety of supports given to the investor, and then finally to see that the project is completed. This schedule shows, I'm just looking at the history. The schedule would have been prepared by the end of 2007 with a target 2-year development schedule. All these 2 years is not physical construction, as you will see. The physical construction actually started in December 2008, and the schedule was for it to go on till July 2008. But I know it overshot by about 2 months, and it was scheduled to start producing electricity in November, but the actual date of operation was 4 months later in 2010 March. So scheduling was reasonably good, but not perfect. But see, all the activities were listed so that we don't have surprises. Our client does not have surprises. He knows exactly what has to be done on what schedule. Right. Then a further analysis of the production and the variation of production from month to month. So, and in fact, we examined what happens if we take this project to another location. So we considered Mana as well, but unfortunately, we are in year 2007-8 period, and Mana was not available. The war was still going on. So Mana, although we have stated here, is a hypothetical possibility. And Narakali is in on the Kalpitia Road. Putlam is on the mainland. So how these locations vary with regard to availability of wind. So that also we considered, because we have to give the confidence to our client. Look, you are not in the best location in the country, but we have to tell that to the client. The best location most likely is in Mana, but sorry, we cannot go there. So therefore, and we do not recommend for you to go to the Putlam mainland, because you see the green bar, that means it will give you a less amount of electricity. So therefore, out of the three possible locations, you are in the middle path, which means not the best, not a bad location. So the comfort to the client and subsequently to the lenders that the site recommended by us is a is a reasonable site, but not the best. So equipment transport chapter, land related studies, environmental studies, financial feasibility. Now, we conducted the financial feasibility. Of course, most of the time we engineers double up as financial analysts as well. Maybe because we understand the costs and operational details of equipment. And I do remember this project with it had a most likely it had a project IRR of about 12% and equity IRR of the order of about 18% of that order. So, and by estimating its production of electricity very conservatively, because one thing that we never want to do is to be too optimistic, assuming that the best wind flow will come all the time, or there will be no equipment outages. Because anyone can say, I will have the best maintenance staff in the world, so therefore there will be no equipment outages. We would not agree to that. We would say, no, any power plant has a 5% unforeseen downtime, and we must factor that in. And you cannot assume the best wind flow for all the years into the next 20 years. There will be interannual variations. And you cannot assume that it will produce the same amount of electricity every year for 20 years, 20 years being its lifetime, because there will be degradation. So we have to assume a certain amount of degradation based on international experience. So the financial feasibility study includes all that, because the incomes comes from electricity sold, and the electricity sold is gradually going down. Unfortunately, because it is a study for a client, I cannot put on the screen the spreadsheet with which we did the financial feasibility study, but comprehensive financial feasibility study and many scenarios developed. What if, what if, what if? So, and that's how the financial feasibility was confirmed. But then that was not over. Transportation was difficult, as you see. In fact, I've taken this picture from my house. This wind equipment is now going from left to right. This truck is moving from left to right on its way from Colombo to Butlam, and it is occupying a fairly wide section of the road. So there were difficulties, but then these were overcome, sometimes with a little bit of delay as well. So now, before we go on to my other examples, maybe I have to perhaps tell you how this project was financed. Now, I said I will tell you a few anecdotes as well. So one day we were sitting with the lenders. So our client said, "I'm going to meet my lenders. Please come with me." And we went. And one of the bank representatives has a newspaper cutting from an Indian newspaper. So, what does the newspaper say? Wind power plants in Tamil Nadu are producing electricity at a plant factor of 17%. At a plant factor of 17%. So this banker is asking, I read your feasibility report. Let me show that here. I read your feasibility report. I'm talking about the second bullet. I read your feasibility report, and you are saying that it will have a plant factor of 31.6. Now, the plant factor or the capacity factor, for those of you who are non-technical, depends on the wind flow pattern. Because if the wind flow pattern is poor, which also implies that the siting is poor, the location is poor, although you have megawatt, it produces electricity only 17% of the time of the year. So this banker, a senior banker, I still remember about 12 years ago, he shows us the newspaper cutting from India and say, in Tamil Nadu it's 17%. How dare you say that in Sri Lanka it will be 31.6? Tough technical question. Tough technical question. But my colleague, who is our company's wind specialist, we came back to the office and rechecked all our calculations. And he said, after another day or two, he said, I stand by my calculations. And we investigated what's wrong with the wind turbines in Tamil Nadu. So when we had the next meeting, we had the following to tell the lenders. We are sure of our calculation. There's no doubt. If you use this equipment, our client can produce this amount of electricity, which is almost double the quantity of electricity that they are getting from the same equipment in Tamil Nadu. So the lenders asked me, how dare you say that? Are Indians so bad? We had done our assessments and of course checked the media and other data. And we had to educate our lenders, Sri Lankan banks. It's not a problem with Indians, or it's not a problem with wind equipment. The problem was in India, was as follows. At that time, India was providing a lot of incentives to companies to invest on wind power, particularly Tamil Nadu. The incentive was as follows. If you invest on wind power plants within your balance sheet, you will get 100% depreciation in the first year. That means if you spend $10 million for a wind power plant, in Sri Lanka, he has to follow the accounting standards. In India, during that time, special concession, you can depreciate it in your annual accounts in the current year. So you buy a wind power plant of $10 million in December, and when you conclude your annual accounts in March, you depreciate that entire power plant within that year. So I'm sure you are familiar with this accounting. That effectively means the tax office pays for your wind turbine because you depreciate it over 1 year. Whereas this kind of equipment should be depreciated over at least 10, 12, 15 years. So we asked Indian equipment suppliers, oh, that's fine. So what's going on? You fix the same machine in India, it produces less electricity. So they explained to us as follows. We get a lot of orders towards the end of the year in the run-up to the end of the financial year. In fact, they said, sir, don't come this way to discuss Sri Lanka projects between November and February because we are very busy. We have a lot of orders. All the big companies want to invest on wind turbines. So therefore, they find a land somewhere there, no feasibility reports. They just get the land allocated somehow and plant these wind turbines here and there to get the tax concession. So therefore, these investors, and perhaps their bankers as well, get their equipment almost, okay, let us say, free. So therefore, they are not too concerned like the investors in Sri Lanka on how much of electricity they will produce. So they are not going to the best location. They will fix them in the locations that are available. So for that reason, the fleet of wind equipment in Tamil Nadu in particular, and perhaps almost the whole of southern India, even today, display a capacity factor of 17%. Sri Lanka 31.6. In fact, subsequently, bigger wind turbines came in, and even in Putlam itself, there are projects that are operating at 34 to 35%. Now, do you think the lenders believed our story? Actually, I respect the lenders who actually conducted the due diligence on this project. They said, all right, we tend to agree with you, your calculations, but we want to get a second opinion. So jointly, we found another group of specialists in UK who were requested to take a second look at our calculations and reconfirm that this power plant will produce so much of energy when fixed in Putlam. So just imagine the depth to which the lenders went with the agreement of the investor who was our client. There was one other requirement that our client, us, as well as the lenders wanted. the equipment to be proven. Remember, I explained to you the development of wind equipment is very fast. Over 10 years, the size becomes double. So therefore, the tendency is always to go for the latest. But then in engineering or in manufacturing, there is a danger in going for the latest piece of equipment. The reason is that the operating hours or years of experience is lower. The manufacturer himself may not have discovered the design problems unless that piece of equipment has been in operation in various wind regimes in various countries for an adequately longer period. So this particular equipment we recommended to our client already had a 5-year operating history in different locations in the region. We got a lot of pressure. Why are you fixing an old machine? We have a brand new machine. It's nice, it's bigger, it produces more electricity for you. It uses the latest electronics on its generator. You can even start it from your home. You don't have to be in Portland. Approach. And I can tell you that really paid off. This equipment was fixed in 2010 and it started producing electricity, and it ran very well without any major mishaps throughout. Of course, subsequently there was a fire in one of the equipment. But as I told you, or rather I will explain it later, as soon as this project was completed, that built confidence among the investor community. And there was a flood of applications and a flood of projects of wind power to be built in Portland. As you can imagine, Sri Lankans, when you see one successful project, all the investors want to do the same project in the same area, harness the same resource. And several companies, not our client, went for cheaper. Some of them went for cheaper equipment. Some of them went for most modern equipment. And I will tell you a story. About 3 years after this project started producing electricity, I was on my way for a casual visit to the site. And suddenly on the road, I see a wind turbine being transported in the reverse direction towards Colombo. Now that can't be. Wind turbines can only go from Colombo to Portland or Trincomalee to Portland. Why do I see a wind turbine being transported in the reverse direction towards Colombo? So we inquired to find out that the power plant adjacent to our client's power plant, which was built in a great hurry using a different piece of equipment, in fact, all the wind turbines had to be replaced. True, the equipment manufacturer would have done the replacement, but imagine the value of the idling investment and the loss of the opportunity to produce electricity, which definitely would have been a severe loss to that investor. So, going for proven equipment, we were happy that we did not recommend the latest or the cheapest for our client. Now, with all this, as you see in the last bullet, this group of lenders in Sri Lanka was so tough because this is the first project. They offered a debt equity ratio of only 50-50. Whereas all the other renewable energy projects before this and after this were offered at least 60-40 and many of them 70-30, with 70% coming as loans from one or several lenders. And that was not more. That was not all. As you know, this kind of projects are off-balance sheet projects. We also call them non-recourse financing, which means the project stands on its own and the assets of the project is the collateral. If the operator fails or the investor fails, the bank should be able to take it over, and the value of the asset should be adequate for the bank to recover its debt. So that was the experience with most of the mini hydro projects that the same banks financed over the 10 previous years. But the same banks who were very nice to us when we were talking about mini hydro projects were very tough when we were talking to our clients, where client was talking to them about this first wind power plant. And they wanted collateral, so therefore it was not project finance. Although for other technical and legal reasons, the project itself was a standalone company. The debt to the project company had to be supported with collateral. So it was not non-recourse financing. It had recourse to the project owners, in fact, personal assets as well. So that's the degree to which, in a way which I like, the lenders of Sri Lanka were cautious about. And it paid off because the project was designed very well and it was done very well. And today it is operating. And this is the almost completed project. And the famous crane I told you of is on the left-hand side, the green color one. It's a giant. You can see it has to be taller than the wind turbines. So this is virtually the almost completed project. And of course, once this was completed, remember there was a lot of misconceptions whether there will be wind in Sri Lanka, whether these will stand or whether these will fall off, whether there will be a lot of noise. Science and financial analysis and modeling and good engineering practice caused the project to be a reality and a good example on how a small wind power project could be done in the small economy of Sri Lanka. And as soon as this happened, the investors were falling over each other to build wind power plants in Portland. So now Sri Lanka has a total of 18 wind power projects, out of which one is owned by CEB in Mana, and out of the balance 17, possibly about 12 are in this same zone, either north. You are looking at the north of this. In the picture, you are looking at the north. So further north, there are several wind power plants, and further to the south, also there are 2 wind power plants. A total of about 12 in the same area. So that's, in my view, a reasonably success story of how a project of relatively new technology was implemented and which I would like to call a success. Of course, being the first, the Prime Minister wanted to come and declare this project. I was surprised, it's 10 megawatt is very small. Why he wanted to come and declare open? Of course, that was also facilitated. And flood of projects have since been implemented in different locations in the country. Now, I said there are 17 private projects at this moment, and at least one of them is making financial losses. Why is that? About 2 or 3 of these 17 projects are in the hill country. And that one produces 17%, whereas at least 32% elsewhere in the country. Now, there's a story behind this project. This project came to us from their lenders approximately 2010. So the lender to the project, which I'm saying is making losses even today, contacted us and said, we have a project in the hill country. Sorry, I will not mention names of companies. We have a project in the hill country. Can you do the due diligence, technical due diligence? They already have a design, tells the banker. So we said, yes, we can do that. But we have to caution you, we told the lender, we have to caution you that the hill country has two problems. One is transporting equipment along the winding roads is difficult. So therefore, the equipment has to be shorter and lighter. That means smaller, older designs of turbines. Number one problem. Number two problem is that if the wind is flowing at, let us say, 20 kilometers per hour in Puebla and 20 kilometers per hour in the hill country, will give you less electricity. Why? The air is lighter over there. This is physics, not even engineering. Physics. When you go up and up, the air is lighter. So you have a wind flow at 20 kilometers per hour in Putlab, and the same wind, if you measure 20 kilometers per hour in the hill country, will produce less electricity. So therefore, one has to be very cautious in the technical and financial evaluation. Sadly, the lender to this investor never came back to us. He made an inquiry and never came back to us. And we really do not know whether the investor actually borrowed from that lender. We do not know that. But on the day we heard that this power plant was built, we were the saddest because we knew it's going to make losses. And if you look at the CEB data book, it shows that it produces electricity at 17%. So maybe the investor considers it as a success. We do not know. That could be possible if somebody gifted him wind turbines, which is most unlikely. But he is producing approximately half the amount of electricity, so he must be making losses. But he was a wise man. He did not build a huge capacity. He stopped at 3 megawatt. He did not go for his 10 megawatt full approval. I'm sure he realized that he was making losses. So the importance of getting the correct and good advice, and for lenders to look for good technical information. I will digress a little bit and talk about hydropower plants. I'm sorry that all my examples are from the electricity industry. Now, I'm sure you are aware that Sri Lanka has more than 200 private hydropower plants of varying capacities. And all these were financed by Sri Lankan banks, most of them private sector banks, sometimes in consortium with government banks as well. But the private banks are leading. The story that we often hear from lenders is that such and such a project, the borrower is not repaying. He's always asking for rescheduling the loan. And we have looked at a few cases. What has happened is that the investor did not get a good water flow report done. Technically we call it a hydrology report, a scientific analysis from an expert who will not give you optimistic figures, but give a good assessment of the water availability of a mini hydro siting location. But if your hydrology consultant is a man or lady who is too optimistic, if he wants to please you, if he wants to tell you that this is a good site, because the client also wants to hear that this is a good site, it is possible that the hydrology consultant is not conservative. He will give you an optimistic figure. And the investor borrows, and the lender lends, and the project is built. And after the first year, everybody will be crying. There are at least 2 dozen projects of that nature. They are not absolute failures, but they are not producing enough returns to the investor. So these are, one of the few anecdotes in the mini hydro industry. My last example in wind power is about a power plant that was never built. A power plant that was never built. The project came to us about a year ago to examine why it was not built. Because the potential investor is still complaining that various government agencies did not support him. So we examined the documents to find that his feasibility study was all fictitious, and he has been shortcutting procedures and lost a lot of time, owing to nobody's fault, which caused him to miss all the deadlines given by CEB and various government agencies, and he could never build it. And his feasibility report says the wind speed of his location was 60 meters per hour. And as you know very well, particularly these days, anything about 40 kilometers per hour is a cyclone. So here we have an investor who did not even bother to make a measurement of the wind of his site. He just imagined a number and put it in the feasibility report and got approvals. Of course, some of these government agencies have given him approval. And finally, a lot of displeasure and bad feelings amongst many people when such things happen. So I will not give you a lot of details of that because some of you might know what the project is. But then these are our experiences in supporting renewable energy projects in Sri Lanka. And at this point, I will pause a little bit because my next 2 examples are going to be shorter. I do not have a lot of slides for them. But these are the real life stories that I can share with you about the renewable energy industry. So if you have any questions, either on project financing, costs of projects, feasibility studies, interest rates, returns on investment, and project development or investors, I will be glad to try and answer those questions. So anything particularly on renewable energy, your questions are most welcome. I'm sorry, I don't have much experience in the manufacturing industry, except for from an energy point of view on energy efficiency, etc. So I will pause here for a moment to allow you to talk.
Yeah. Please ask questions from Dr. Siebula. Can I ask first question, Tilak?
Oh, sure, certainly.
Because now you said wind power.
Yes.
The efficiency is about 31 to 34%. Right?
Yes.
Whereas solar power is low, around about 20%.
Solar is lower because wind flows throughout the day, but of course seasonality is an issue because I'm talking about an annual figure. So and inter monsoons and low seasons, all of them are averaged. But solar, as you know, the best we can have is 50%. If we have full sunlight throughout the 12 hours, that also we don't have. So therefore, solar goes in a curve like this, and in the night time it is dead. Solar is about 17%.
Okay. So you take the 24 hours and take that's why
That's
it's
right.
very
Yes, yes. Because the equipment is there all the time. So the equipment lasts for a year. So we need to calculate how much of electricity it can produce.
like this wind power turbines. So 1 megawatt is one tower, is it? You said one project.
Depends. Say this example that I was talking to about. One tower was 1.25 megawatt. Whereas the latest project done by CEB, their own project in MENA, is 3.4. So it's more than double the size of the Putlam machines. They are
So it
large.
is you invest less and you get more power. Actually.
Yes,
Because-
when the capacity is bigger, what happens is the blades are longer, so therefore they capture more energy. Because although they look very complicated, the principles are relatively simple. When wind blows, the blades, the wind pushes the blade. Of course, the wind cannot push the blade onto this side. It pushes in such a way that it can rotate, and the rotation causes electricity to be produced. So the wind coming towards wind turbine, when it leaves at the back, the wind speed is lower, the energy is lower because you have harnessed a certain amount of energy to turn the blades. It's just a reverse action of your ceiling fan. Your ceiling fan is having a lower speed and then adds energy and pushes it down for you to have your comfort. It's a reverse of that.
Okay. So after careful studies, you have to have the blades in the correct direction.
That's right, in the correct direction, correct sizing, because we can theoretically calculate how the blade should be, but you go to the market and you have only a specific number of designs available. So what we usually do is we look at the, first of all, equipment that has operating experience. Then secondly, equipment that can be transported to the site, depending on the roadways, etc. So after these two are decided on, then it's a matter of selecting a few models, and of course, in the analysis software, you plant that wind turbine in Putlam, if that is your site, and that will give you the expected amount of energy. And then you, of course, have to make corrections because wind turbine, although we like it to run 100% of the time, they also have to stop for maintenance. And there will be some problem, unforeseen issues. We have to suddenly stop them for emergency maintenance. So we have to leave allowance for that.
So now the crane lifts the turbine, the blades.
Yes.
Who goes and fix it? There should be.
Yes, actually, first of all, the hub is lifted. The hub is lifted, and the hub is kept on the top.
Okay.
So, in fact, Indians do it in a very sometimes I feel it's very unsafe way as well, because they use ropes and all these things and push it to position with some people actually who are inside the tower. There are people inside the tower, so they do the final alignment first, put the hub, the axle, let us say, and then the blades are lifted by two cranes together. And obviously that is done with a lot of difficulty by people climbing and sitting on the hub, and they signal the two cranes to do the alignment, and they put the nut and fix
Oh,
it. So it's relatively crude. Actually, I also don't see any better way of doing it. But maybe in Europe they use special instruments and laser guided alignment systems, etc. But here it was done in a very crude way.
So maybe only Indians can do it, is it?
Yes, of course, Indians, they follow the Europe because these are European designed equipment, but being installed by Indians, so they follow the European standards. But when it comes to the last point, they behave just like Sri Lankans. The little bit of the last thing is done, perhaps in the Sri Lankan way, by making some on-the-spot adjustments.
Okay, so I think I asked too many questions.
Any questions from my audience?
I might have to name you.
Very quiet audience I have.
There are my favorites who ask questions. And Nuani, you are the first one. You have any questions? Actually, Nuani works for Union Bank. She asked, they are a small bank. And when I said that we need to get a consultant to analyze the project, like a second look. So how can a bank to spend that amount of money to pay a consultant? Nuani, please.
I just want to know, sir, in terms of Sri Lankan energy sector, now we have hydropower is there, then wind power and solar power comes. Then as per the resources we have, what would be the most attractive type of energy that we will be using in the future? I mean, like, will it be wind power or the solar power?
Yeah, it's a combination of several factors that will decide the mix. Number one is the technical performance in the system, because as you can imagine, unlike any other commodity, electricity has to be produced exactly at the same time the customer wants it. So when you put a switch on, actually, do you know that some valve in a power plant, could be water, could be coal, or could be oil, it opens slightly to produce a little bit more electricity to allow your light to switch on. Now, if you consider an extreme situation that Sri Lanka has only solar power and all the solar panels are running at full capacity at 12 o'clock midday, when you switch on the light, where is the additional electricity coming from? So therefore, my simple example will tell you that one technology cannot be standing on its own. It has to be a mix of technologies. And my simple example didn't go as far as to keeping the system dynamically stable, because production and consumption being equal is managing the network in a dynamic fashion. So then there are certain types of power plants such as oil power plants, gas power plants, coal power plants, nuclear, which help to keep the power system stable, so that when you ask for the next unit of electricity, it can provide it. But of course, these technologies I told you of have their significant drawbacks. Nuclear has its, I don't have to explain to you, coal has its limitation, gas has its limitation. All of these are fossil fuels. Nuclear is what it is. But then renewables are generally insulated, or rather, they do not have this kind of adverse impacts on the environment. But their problem is they produce varying amounts of electricity. Their production levels are dependent on the resource availability. So how do we match the two? Matching the two requires a lot of analysis, both technical as well as commercial. Now, if I give you an example on the commercial side of the game, is that solar rooftops are purchased at 22 rupees as an incentive. Of course, I personally say that it's too high. Let us say it's 22 rupees. But how many of us pay more than 22 rupees for electricity? In fact, in the manufacturing sector, nobody pays more than 22. In the commercial sector, the commercial buildings pay some 22 something. And 95% of the households in the country do not pay 22 rupees. So therefore, there's nobody buying electricity at 22 rupees. It's only producing. So therefore, this commercial reality has to be balanced. So for that too, you need to have power plants such as big hydropower plants, which are producing at 350 or 4 rupees, as well as coal power plants, which are producing at 9 rupees. So that to ensure a commercially viable network also, you need a mix of these resources. So it's a technical requirement and a commercial requirement. To balance the environment and sustainability and meet all the objectives, it has to be a mix of all of them. And that, of course, is a result of a long calculation. Of course, as you know very well, politicians are very fond of making announcements without doing any calculations. And I only feel sorry for them. Some of them say we will go for gas. Some of them occasionally say we will go nuclear. Others say I will do only solar. But then the real solution is a mix of them.
Some say only renewables. We can run the country only with renewables also. No?
Yeah. Because of what to do. In fact, I tell them we don't. When it comes to the extreme, I actually ask them, what is your son study? So he says, oh, he's doing engineering in Monash. So I told him, look, your son has nothing to do because you have decided the engineering solution, right? And indirectly the commercial solution as well. So the bankers, engineers have nothing to do. The politician has made the decision without looking at facts. So of course there are such people in all countries, but we have a bit more than other countries of that caliber of people.
Right. Anyone else? Anuradha, you have any questions?
I think those.
Maybe we can go ahead. No? Yeah. Okay.
You have a question?
Oh.
No, I have time. No problem at all. Anybody has a question?
Maybe you can do.
What I was going to say is that when you mentioned Union Bank, I have a story. One day I had this is probably about 15 years ago, I had a telephone call from the Union Bank CEO. In fact, at that time, my office was only 50 meters away from Union Bank head office. Can you please come? So we crossed the road and went there. You see, we financed a power plant in Jaffna, and the borrower is not meeting the obligations. Can you analyze this for us? He was hired by the government, that is CEB, to produce and supply electricity to Jaffna until the network was reconnected to the mainland. So I'm sure you are familiar with the recent history of the country. This is just 10-15 years ago. Jaffna was disconnected during the war, but Jaffna was normalized well before the other parts of the country. So therefore, the government in 1997 wanted to supply electricity to Jaffna with a local power plant.
I remember that. Yeah.
The connection to the south was broken, and the war was still going on. So this power plant was not performing. Power plant was actually not operating properly as well. Because of that, CB was imposing penalties. So the investor was saying, look, CB is imposing penalties on me. So how can I meet my lender obligations? How can I pay my loan? So we made a visit there, under all this security and all that. My staff went on the plane and, all these dangerous plane rides to Jaffna those days. So to examine what is technically wrong with this project. But basically our assessment was that the investor was not keen to run this project as a going concern. He was not doing the maintenance properly. It was after about a month into this analysis One day I asked, how much did you lend to this man? And I think in this case, I can mention the name. Bank of Ceylon was also in consortium with Union Bank.
Yeah, I know.
You remember, right? So I was given a figure. So I said, my God, this project is not worth it. You have lent him X, but the total value of this project is half X on day one.
So the promoter has already made the money.
Promoter made his money on day one when he had ordered the equipment. I'm sure he had a deal with the equipment supplier to give him the correct invoices to show to the bank. And thereafter, he made his money on day one. So why should he bother to run this power plant and earn money? And that was the reason. Unfortunately, the project finally went down and down and down and crashed. I really do not know how much the banks lost. Probably at least half X was the loss to the bank.
Yeah, we have similar experiences.
All right. So therefore, not only the technical viability, but checking the costs of the power plant. Because right now, the failed wind project that I was talking about, in fact, this whole afternoon I was talking to the British lawyer challenging the government, British lawyer supporting the government in the challenge by this investor, saying that the government ill-treated me and therefore I could not do my project, pay me some damages. He overpriced, he means the investor of the failed project, overpriced his project by 3 times. His project was worth only $70 million. And he told his lenders, he told his partners, he told the government of Sri Lanka that my project is worth $350 million, whereas in my assessment, his project was worth only $70 million. So, sorry, it is 5 times overpriced. So, I'm glad that for some reason, for some delay in the government of Sri Lanka or somewhere, this project did not go through. If it went through, all the parties would have been unhappy except the promoter, the equipment supplier, the lender, his business partners, CEB, the government of Sri Lanka. Everybody would have had a dead project which does not produce electricity, not knowing what to do with it, and somebody would have taken a lot of money and run away.
The banks would have checked,
Well,
there are 17 projects have been done already. 16 or 17. You know how
Yes.
per megawatt how much it costs approximately.
If it was a local, these were not local banks. If
Not local banks.
if
Okay.
they approached the local banks, I'm sure he would have been shown the door at the first meeting itself. Because I consider our bankers, I've dealt with them quite a lot, most of them to be adequately tough. We generally see, of course, some lapses in the energy project financing, but generally, in my view, they are very tough compared with others I have met elsewhere. But this particular investor, who was 5 times over invoicing his project, has been taking the bankers for a ride for about 1 year. I see documents issued by the bank. We will support, I'm this bank, that bank in such and such a country, and we do international project financing, and we hereby support your project. And he has submitted those letters to the government, etc. So I'm glad that none of the local banks were involved. Probably he checked and found that local bankers were very tough and would not even talk to him. So he went abroad. Investor is not Sri Lankan, he's foreign. So, fine. Then I think only a few more things for me to share with you. I think, do you still see my slides? No?
Yeah.
You do, but I had to put it on the display mode.
It's not the presentation mode, it is.
Yes, right. You see the presentation mode now.
Yeah.
I wanted to briefly talk to you about a transmission line in Bangladesh. Now here, The transmission line was being built by their own electricity board, but they wanted to borrow from an international bank. As you know, international banks are lending to government projects which are for public benefit at concessionary rate, and the rates of concession depends on the economic status of the country. So countries like Bangladesh still get uh, very significantly low interest rates. That means very good terms from international development financing institutions, whereas Sri Lanka also gets, but not as concessionary as they get in Bangladesh. But my story
Maybe
is
we don't get, but now we borrow from Bangladesh at commercial rates.
that's a different story. I must tell you about that as well, but after I finish this story.
Right,
So
okay.
so Bangladesh proposed to an international financing institution for a concessionary loan to build a 175-kilometer very long transmission line, almost from the southern coastal area to Dhaka. The project was estimated to cost $175 million. So I, together with my engineers, went for the due diligence on behalf of the bank. And when we were conducting our due diligence, looking at examples, looking at experiences of other countries, we realized that technically it's all fine. Our calculations indicate the power will flow, the currents are okay, engineering is fine. But we were worried by the cost estimate. We were worried by the cost estimate because our estimate was about 25% lower than the electricity board's estimate. And our fears were strengthened one day. After a meeting, I was coming down the stairs to go out of the headquarters building, and a young junior engineer comes behind me and says, Sir, shall we go and have a cup of tea? Now I was surprised, why is this young engineer asking me, Sir, can we go and have a cup of tea? And the time was also around 4:30, offices were closing. So I said, okay, it's all right, let's go. And two of us went with him to the canteen, and we were sitting there. And he was explaining, Sir, I know you are evaluating this project. I'm sure you will tell the government their cost estimate is too high. That is going to make, because Bangladesh Transmission Company is a corporate, it's a government-owned corporate. So even the youngest engineer working there is worried that his transmission company profits will go down if the company overspends on a transmission line. So he was going to buy a cup of tea for me and get me to tell his bosses tomorrow that the cost estimate is too high. So, which I did. In fact, we had already were forming our opinion that it is on the high side, but then nobody would listen to me, including the International Financing Agency project officer would not listen to me when I said, look, it's too expensive. My estimate is as follows. So shall we sit down and redo the cost estimate? Because I'm sure maybe some of you are still learning the trade. In a government agency, these cost estimates are published, or they get to know because the International Financing Agency says, they put out a press release saying that we are going to finance a $175 billion transmission line in Bangladesh. And 2 weeks later, Bangladesh issues a bid document. We hereby call for bids to build this transmission line. And the bidders put the budget. And they, of course, as you know, once the budget is known, everybody will bid very close to the budget. And if the budget is wrong, who is going to lose? The Bangladesh Electricity Board. And my poor junior engineer who is working there, he's going to perhaps lose his bonus this time because his company is going to make losses for a few more years owing to overspending on this line. So then I came back defeated. Nobody agreed with me. Me and my engineer came back defeated. About a month later, another project officer from the International Financing Agency calls me and says, can you take a second look at this project? Can you come to Bangladesh next week? So I said, of course I will come. So went there, had a discussion. And then he said, can you evaluate the foundation experience, foundation expenditure on this line? So I said, we are electrical engineers, but I'm sure you can find somebody from Sri Lanka. I'm sure, you have good people over there. So he pushed me. So I came back, got a good structural engineer to completely redesign these foundations for the towers. And finally, we made a detailed cost estimate, which was 25% lower than the estimate from the electricity board. Now, by this time, the bid documents were out, and possibly somebody in Bangladesh would have leaked the information that the consultants to these projects have made a cost estimate 25% lower than the announced estimate. And the bids closed in about 2 months later. Bangladesh got bids 20% less than the budget. So it was not as low as 25%, but it was 20% lower. And $1 million into 175, 20% less is $35 million saved for Bangladesh. Because of that alert project officer and that alert young engineer who bought a cup of tea for me and pressed me to, tell the bosses this is too expensive. And me and my engineer, we are happy that we saved $35 million for Bangladesh. Now, the last part of that story is I'm sure Bangladesh similarly has other amounts of money saved like this so that they can lend 100 million, 200 million to Sri Lanka. I have a story behind that, not my 35 million, but Bangladesh is going very fast in gas power generation and coal power generation. So I'm sure some of you have heard of a power plant called Sampur in Trincomalee that was to be built, which was cancelled by our 2015 government. I'm not talking politics, but I have to give you the dates. You know who the president was in 2015. One morning he woke up and said, I don't like the power plant in Sampur, I hereby cancel it. At the same time, Bangladesh was negotiating with India to build exactly the similar power plant, but 3 times in size in Bangladesh. So Sri Lanka cancelled the project. Bangladesh proceeded with the project, and in 2 months' time, it will start producing electricity. At less than half the price, Sri Lanka is now producing electricity. So come next year, Bangladesh will have not 100 million, but $500 million to lend to us. For what? To buy oil and produce electricity. All right. Okay, these are anecdotes. And finally, of course, we have only about 15 minutes more. Public projects in Sri Lanka. Possibly banks are asked to increasingly lend to public projects in Sri Lanka. Sometimes the political pressure is also too high. And increasingly, not only railways, but other public projects, we see going the same path as my tiny example in Bangladesh. The cost estimates are way above what they actually cost. The cost estimates are way above what it actually costs, because the traditional costing approaches are being suppressed by various interested parties and replaced with their own estimates, which basically increase the budgets for projects. So the most recent example is the railway project that was planned and so far put on hold I'm not referring to the light rail project. I am referring to the Colombo Suburban project. Colombo Suburban means upgrading the existing network, not the elevated network, upgrading the existing network. And when we examined the cost estimates, the design features, etc., we see a very deliberate attempt by various people to oversize the investment. So if you say that there are 200,000 people traveling on high-level road towards Colombo in Maharagama, first of all, we have to check whether that number is correct. And then if you say that that number is going to be increased by 50% over the next 5 years, then we have to examine are the travelers on high-level road increasing at 10% a year? Is it a reasonable estimate? Or are the people going in both directions rather than in one direction at peak time? Then next, if somebody assumes that 50% of the people traveling on high-level road will actually get onto a train, then we have to examine what is the experience of other countries. Singapore, which has a good railway system. UK, good railway system. A railway running parallel to a roadway. Whatever you do, the international experience, even in Singapore, which has a very efficient railway system, is 35%. So if you have 200,000 people going on the high-level road towards Colombo at 8 o'clock, if you have a super railway system, only 35% of them will climb onto a train. So you have to size your train to that, not to a fictitious figure. Because if you size your train to match that passenger demand, your investment will be lower. Number of sets you have to purchase will be lower. So the project design, unfortunately, in our assessment, it was an over-design. Then secondly, project costing. The project costing, the international norm is $1 million per kilometer of track on the ground, not elevated. If you look at the Sri Lanka cost estimates, it's $2 million. How can that be? That can't be. So therefore, if the lender and the government is cautious, these design features and the estimates will be corrected. Now, what happens if they are not corrected and still goes forward with some lender coming forward? That lender could be another country or an international financing institution or a commercial bank. That lender will be in trouble by lending to projects that are over-designed technically and overpriced. So therefore, infrastructure projects generally provide a good cash flow stream. As you bankers call it, some of them may be seen as cash cows. But then one has to be extremely cautious in evaluating the feasibility, technical, costing, and financial feasibility. So that's the last word of advice that I have to give you. Of course, experiences are many because public infrastructure projects are rushed by political ambitions as well, as you know. There are many examples of projects that perhaps we should not have done at this magnitude, at this price. So that's why perhaps some of the difficulties our economy is facing at the moment is most likely because of investment on projects that are not yielding economic benefits. I'm sure you have been introduced to the difference between financial evaluation and economic evaluation. So, say for example, if the railway project is properly designed, And if the correct number of people get into this, Sri Lanka will need to import less amounts of oil because there will be a fuel saving. There will be a reduced requirement for road building. In the longer term, this don't happen overnight. So just imagine if we oversize this railway system, assuming that an exorbitant number of people will get into it, and that does not happen. We have over-invested on a project, and the benefit to the economy by way of reduced oil imports is not happening. And we have to pay the lenders to this project at whatever repayment terms, but still spend money to import oil and sell it to the people who are not taking this trade. So it has a severe impact on the foreign exchange reserves of the country. And one example is the Southern Expressway beyond Uttara. If you do an honest economic analysis, it should not have been built. Because the economic benefits are not justifiable. True.
But that is better than the airport and the port, I think.
Of course. We are glad that the government suspended the rail project pending further analysis. We are glad that the government suspended it because we already have a port which has very few ships. We have an airport which has very few planes, and we have a conference center in the same area with no conferences being held. And we will sadly would have had a railway system with no trains, no passengers. I don't say it will be zero, but over-designed. So therefore,
we have international cricket stadiums all over the country, and they want to do another one when there were no matches.
That's right. So therefore, we have to be very cautious, particularly in a country where our foreign reserves are extremely important. So, of course, as a power sector economist, I actually most of the time feel very sad that some of the power sector projects were either not done or done at a higher price or not performing well, and finally not bringing the benefit that they should have brought in to save the precious foreign exchange. So, say for example, most likely, if we did not build the Southern Expressway, we would have, at least theoretically, we can say we would have enough money to buy the vaccines without begging around all over. So, so many anecdotes that we can relate where projects have gone wrong. So, utmost, particularly in infrastructure projects, is what is required. That brings me to the end of what I wanted to tell you. Of course, more questions are welcome.
Okay, Tilak, thank you. Questions?
You have a very obedient class. Yeah. Very obedient class, I think.
Obedient class.
They are very shy, or of course, we have questions.
We Sri Lankans are like that. No? The problem is we don't want to ask.
Yes, that's right. And the tendency to ask questions is again diminishing. Say, 10 years ago, when I go to my undergraduate class, when I finish the class, I can't come out for a further half an hour because there are so many questions. And it was not long ago, it's about 10 years ago. But now I go to the undergraduate class, no questions.
Moroto University, is it?
Yes, I ask the question and I give the answer as well.
Right.
So, but anyway, I have to tell you, I'm sure most of you are very young. We must have a questioning mind. We should not accept what anybody says without question.
When we are actually doing project finance, we should always ask questions to find out what is happening.
Very intelligent questions as well, because as you know very well, there are investors who are out there to fool the banks.
Yeah.
right? So I'm sure the tricks of the trade, as employed by the investors, when they justify projects in front of you, they will show you how good their project is. And so I'm sure the bankers, the senior bankers, your project finance division still have some good people from the 1980 era who know the importance of asking the right questions, conducting the proper due diligence. And as I have experienced, most of them simply do not let go a bad project. They do a very good due diligence. I don't have any recent experience in projects in Sri Lanka, but I hope that those professional standards are still being upheld. Because if you give them up in our banking system, I don't have to tell you what it will happen to the banking system. It has happened to the government system because of the reasons I told you of. And if the same thing happens to the banking system, then it will be a disaster. So I hope the bankers are taking good note of project finance and the importance of conducting good due diligence.
I think that's why they are following this course also to get their knowledge to
Sure.
analyze project financing. Tamika, you have any questions?
Some of you are working in project finance divisions, are you?
No, sir.
No?
Yeah, you don't have questions, Tamika, right? I think there are 4 from the NDB. All 4 are working in project finance.
I see. Okay. NDB is a very well-known renewable energy finance. Yeah.
Yeah.
So
When we were doing in 1990s with the Energy Services Delivery Project,
that's right.
NDB, FCC and HNB, we were, and Sampak.
That's
we were
right.
leading.
That's right. So the private
It's one
sector
value.
done very well. Okay, so we can close now if there are no questions.
Okay. Yeah. Anurag, you have a question? Okay, then, Tilak. Thank you very much. I think I also learned a lot from your lecture. I told you that when I speak to you, anytime I learn something. Right? So,
It's all right. If I start talking, I will not stop till 10 o'clock. So therefore, I was very guarded in telling your audience.
recently I spoke to you regarding our that current account which you are having for
Yes.
emergencies. After that only we came to this presentation because
Sure.
of our discussion. Thank you very much again. Preparing for the presentation and 2 hours educating my students. Thank you very much and all the very best in the future.
All the best to all of you as well. I will meet you somewhere someday, and hopefully you will keep the flag flying wherever you are on conducting good due diligence on projects, because good projects will finally contribute to the improvement of the banking system, your profits, as well as the national economy as well. Thank you.
Okay, good night.
Thank you, sir.
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 Radhika.
Thank you, sir.
Bye-bye.
Don't leave the class. Okay. We only let Dr. Tirak Siamulapidi leave. How was it? Did you learn? He has very good experience in handling power sector projects, and you saw how his knowledge is. Right? And we are coming to end of our official classes, but assignment 2 and 3 I haven't received from Mr. Menaka yet. So I will have to go through that, and we will have a class to look at assignment 2 and assignment 3, whether some of you would have done it correctly. I think most of you would have done assignment 3 correctly. Assignment 2, we will see how your analysis of that Maldives project and whether I can add some more to you. Then I told Mr. Menaka, I think IBSL also conducting feedback of this course. Right? So he will share with you a form, feedback form. Please give your honest feedback. right? So that we can improve the course next time, and so that will give us guidelines to improve. I think thank you, Nuani, for your very good question, and you saved the day for me. At least we had one question. I think all of us have to ask questions. Then only we will learn. Maybe it was too much, but then I think you can ask any question, and he will explain. When I speak to him, he will explain some. When I ask a question for a long time, so he is going into so much detail, right? So that is his specialty. And you see that he is been consulted by international finance institutions for projects in Bangladesh. Right? So he has a very good consultancy practice with his team. I think it's past 9 now. Right? Any questions from me? Isuri? Kumari?
No, sir.
Right. Okay. I think I am going to miss. I have now last 3 months, every week, 2 days, I have been with you in the evenings, Tuesdays and Thursdays. And since we are going to finish the class, I will be missing the class. Right? So, but you can anytime contact me and ask any questions, and we will again have 2 more classes maybe before the exams, but with the country situation, we don't know when the exams will be, and by that time you may have forgotten what you have learned, but try to practice what you have learned, and look at projects. Now, actually, I also normally share with my classes public projects, like Dr. Tirak Sebulak shared that railway project, that is, I think, electrified railway project. He did a study at Institution of Engineers and made a presentation at Institution of Engineers as well, that the project cost is too high. Though the railway department says that is the project cost, right? So look at projects and see what, just have a look, have questions. When projects come to your bank, ask questions, and don't take projects at their face value. Evaluate it in detail, and some people make the project cost very high, so that as he explained that power project in Jaffna, I also know about the project, that they made money before the project is done. Even that wind project, they were going to do and to make money. So after that, there is no one to look after the banks, because they have already made money. So they are not interested in whether the bank will get the loans paid as well. Okay, like that interbatch porcelain I have explained to you, 4 banks lost a lot of money. Right. I think everything good has to come to an end, and we will close the course officially today, but we'll meet again before the exam once or twice to brief you. I will prepare the exam paper so that I can give you some tips before the exam. Good night. Any questions before you go? Okay. No questions. Good night.